Okay, so the other rule to remember is that when you're dealing with polyatomic ions, so meaning more than one element and you have a charge, you do have exceptions to the octet rule in this case as well. And that's because of the coordinate covalent bonds that can exist. So meaning you have one element that actually shares more than just one electron with its bonding atom. So the rules of drawing your Lewis structures are the same. So here we have 3 electrons coming from the hydrogens, 1 from each. We have 6 from the oxygen, and so that's a total of 9. But remember that when you have an overall charge, that has to account. So because it's positive 1, we actually have to remove an electron. If it was negative, of course, we would add them in. So oxygen is our essential atom. We have our hydrogens around here. We do our bonds. So in this case, we've used up 2, 4, 6. We have 2 electrons left over. Anytime you have electrons that are left over and everything else on the outside, so your outside elements are stable, those electrons go on the central atom as a lone pair. Okay, and that's going to affect your Vesper shape, of course. Now remember that when you are doing a polyatomic ion, you have to have brackets and the charge. Now, when you're doing a molecule that is polar, now remember that polarity has to do with the symmetry as well as the types of elements that are bonded. So in this case, we have a lone pair of electrons, which is going to create an unsymmetrical molecule. And the oxygen-hydrogen difference in electronegativity does put us within the polar covalent range. So remember to review that polarity note to review from grade 11 what that's all about. Now when you draw a Lewis structure that is polar, you must show the polarity with the dipole. So meaning in this case, we have a dipole in this molecule because the entire molecule is polar. Okay, so it's not enough just saying that something is polar. If the molecule is polar, it must have a dipole in its Lewis structure. Okay, now in the case with the boron trichloride that I did the first example on, that was non-polar because you have a symmetrical molecule. So meaning there's no lone pairs on the boron, and it's the same element all around the boron. So it's completely pulled in equal forces. Okay, so just a few notes to help you as you move along here. Make sure you go over your intermolecular forces and your unit, prepare for your unit test that will be on Monday. All right, best of luck.